Dundigal. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. Today, I'm discussing about problem solving on dilation and erosion. So, dilation is a process in which the binary image is expanded from its original shape. The way the binary image is expanded in determination of by the structure element. This structuring element is smaller in size compared to the image itself, and normally the size used for the structuring element is 3 by 3. So the dilation process is similar to the convolution process, that is, the structuring element is reflected and shifted from left to right and top to bottom, and each shift. The process will look for any overlapping similar pixels between the structuring element and that of the binary element. So any of that one we are taking for the dilation. Okay, so the dilation is a process in which the binary image is expanded. Suppose I am taking the 3 by 3 matrix. So if I am taking 101, 010, 110, okay, it is a 3 by 3 matrix with a binary image. So this binary will be expanded from its original shape. It is the input. So what is the output of the matrix? Okay, we have to convert to the 3 by 3 matrix to the output. But structuring element is a smaller in size compared to the image itself, and normally the size used for structuring element is 3 by 3. Suppose I am taking another structuring element. So that is a 3 by 3 matrix. So it is a structuring element SE. It is the size is compared to the image itself, and normally the size used for the structuring element is 3 by 3. The dilation process is similar to the convolution process, that is, the structuring element is reflected and shifted from left to right and top to bottom, and each shift the process will look for any overlapping similar pixels between the structuring element and that of the binary image. So the structuring element will then be shifted towards right at position into we find that one of the black squares of B is overlapping or intersecting with the black square of X. But at the position, the square will be changed in black. Similar, the structuring element is a B. So structuring element is B and image is A. So output I am taking as a, after the structuring element, output is a erosion or dilation. Erosion or dilation. So the dilation is an expansion operator that enlarges binary objects. Dilation has many uses, but the major one is bridging gaps in an image due to the fact that B is expanded the features of X. So any of the image input is the input image is A, and SC structuring element is B. Output is a eroded or dilated output is there. So what is the technique of using? So erosion or dilation. So here I am taking one example of dilation. It is the input image and it is the structuring element with 3 by 3 matrix. Okay, it is the input and the output is the dilated output. So what happened here? Here only less number of, suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Suppose 12 cells are black, example, remaining all white. But here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 black cells are there. So what is happening? We are increased the number of blacks or decreasing the white. So that is a reason dilation is nothing but increasing the black. It means here black is nothing but a foreground and white is a background. So foreground is a black and background is a white. Here what is the majority? Foreground is a majority here. Here background is a minority. But what has happened here? White is the background is a majority, but foreground is a black in minority. So exactly opposite. So the blackish background is improved. Here the background is decreased. Here the foreground is increased. Okay, like this. So here in the erosion or dilation, whatever it may be, structuring element is a very important. It is a midpoint of this one. So that is a structuring element. So in the erosion or dilation, definitely we have to take the structure element. That is SC is a mandatory. So input image with the structuring element equal to output is a dilated or eroded output. Okay, so it is the input image, input binary image with structuring element, and the output is a dilated output, dilated or eroded output. So erosion is the counter process of dilation. If dilation enlarges an image, then erosion shrinks the image. The way the image is shrunk is determined by the structuring element. The structuring element is normally smaller than the image with a 3x3 size. So if I am going for the erosion is counter process of dilation. Okay, erosion and dilation is a process, but dilation enlarges an image, then erosion shrinks the image. The way the image is shrunk is determined by the structuring element, and the structuring element is normally smaller. Structuring element SC is a smaller than the image width of 3x3. So image of the structuring element we are taking maximum of 3x3, depends on our input size. So this will ensures the faster computation time when compared to the larger structure element size. Almost similar to the dilation process, the erosion process will move the structuring element from left to right or top to bottom. At the center position indicated by the center of the structuring element, the process will look for whether there is a complete overlap with the structuring element or not. If there is no complete overlapping, then the center pixel indicated by the center of the structuring element will be sent white or 0. Okay, white equal to 0 if I am taking, that means black equal to 1. So let us define X at the reference binary image, and B is the structuring element. X is the input image and B is the structuring element, and erosion and dilation of the output. Okay, erosion or dilation X to B equal to Z of B to Z. So it is the eroded or dilated. Equal to. So at the center position indicated by the center of the structuring element, the process will look for whether there is a complete overlap with the structuring element or not. If there is no complete overlapping, then the center pixel indicated by the center of the structuring element will be sent white or 0. Let us define X as the reference binary image and B is the structuring element. Erosion is defined by the equation. So the equation states that the outcome element Z is considered only when the structuring element is subset or equal to the binary image. So always the binary image or input image equal to X. So structuring element equal to B. So the erosion process states at position there is no complete overlapping, and so the pixel at the position will remain white. The structuring element is then shifted to the right and the same condition is observed. At position the complete overlapping is not present, then black square marked with a star will be turned to white. Okay, black is converted to the white. So the outcome of the element considered with the structuring element with the binary image X. So the structuring element is then shifted further until its center reaches the position marked. Here see that the overlapping is complete, that is all black squares in the structuring element overlapping. When C is overlapped, with the black squares in the image. The center of the structuring element corresponding to the image will be the black, and the result of structuring element has reached the last pixel. The thinning operator that shrinks an image by applying erosion to an image, narrow regions can be eliminated while wider ones are thinned. So, if I am taking the input image and the structuring element SE, and it is a eroded output or erosion method applied. So, erosion is what happened here, number of white. So, here background white is increased, background white is increased. Here foreground or object is decreased. Here what is happened? Object is increased, foreground is decreased. So erosion is improved from the input to the output with the help of structuring element. So erosion is one of the most useful and simple morphological operation in digital image processing. So what are the morphological operations? Erosion, dilation, closing, opening, hit or miss. So the morphological operations are erosion, dilation, closing, opening, hit or miss transform. So in this morphological operation, first one is a erosion. So we will discuss today erosion and dilation. So erosion is one of the most useful and simple morphological operation in the digital image processing, and erosion takes away the pixels lies in the border of an object in the image, or it takes away the irrelevant shape details in the objects. So erosion shrinks the image. Erosion is a shrinking the image, means reducing the image. Dilation is expanding. Okay. Here also eroded. It is erosion means shrinked. So how many blacks are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So almost 11 white black cells are there. Here only 1, 2, 3 are there. Are we shrinked the black cells or not? Yes. The foreground or object is decreased, background is increased. Means background is highlighted, object is not be highlighted like this. Okay. So we can also say that erosion decreases the white. Erosion decreases the white and increasing the black area. Okay. So white is decreased and black is increased. That is like this. Okay. So mathematically, let's consider the white pixels are 1 and black pixels are 0. So white equal to 1, black equal to 0. Okay. So it is one example of erosion. It is before going to the problems, these are the basic things to finding out the erosion and dilation. So first we are going for the erosion. First one here, what are the rules for erosion? Means if perfect match of the matrix from the SE, that is equal to 1. If partial match equal to 0, no match equal to 0. So perfect match equal to 1, partial match equal to 0, no match equal to 0. Okay. So here I am taking the structure element SE. So this SE, yeah, I am scanning this SE here. So if like this matrix, so perfect match means anything perfect. Suppose here I am taking 1, 1, 1, 1. Okay. It is like this. Okay. So in for the original image, if anything matched, then it is a 1. If partial match, no, 0. It is also 0. If it is no match, suppose you can observe here all zeros are there. Here 1, 1, 1, 1. So is it any ones are there? Background? No, all are 0. So I'm taking as a 0. Next, partial match. Suppose here I'm taking 1, 1, 1, 1, 1. So here 1 is there, here also 1 is there. The background 1 is there, yes. But partial match also 0, yes, it is 0. Perfect match means, suppose I'm keeping the 1, 1 here. Okay, so here 1, 1 is there, 1, 1, 1, 1, 1, 1. So perfect match equal to 1. So here, compared to all cells, only one perfect match, remaining all zeros. So are we shrinked or not? Yes. Okay. So erosion is nothing but we are shrinking the original image from the input to the output. Okay, that is the erosion, and it is after getting the original image, eroded output. Suppose here it is a original image input and it is a eroded output. Means what is the observation? We can observe that the objects in the image are thicker than the original after erosion. This is because the background color is white and after erosion the white pixels are increased. So we can see here the background is improved compared to this one. Okay, and objects are thicker. So background is improved and objects are thicker. We can compare this one thicker. So you can see like this, compare this one. It is normally just a star, but here backgrounds are improved with black. Okay, so objects are thicker and the background is improved. So that is the advantage of erosion. And another one is a dilation. It is also one type of morphological operator. Dilation is opposite to the erosion. Opposite to erosion. We can understand this one. Opposite to erosion. So dilation expands the image. Okay. So dilation expands. So erosion is shrinking. So erosion is shrinking, dilation is expanding. Is it inversely proportional or not? Yes. So it is the opposite to the aeration, and dilation expands the image. It increases the white pixels and decreases the black pixels. That is W. So decreasing the black, white, and increasing the white and decreasing the black. So why I am increasing the white means the background is increasing like this. But mathematically, let's consider the white pixel is 1. Mathematically, white pixels are 1, black equal to 0, white equal to 1. As dilation is increasing the white pixels, we can denote the erosion is like this. Okay. So if suppose A plus B is there, that means what is the meaning? A eroded B. Suppose I am taking A, B like this. That means A dilated B. So A plus symbol is there, eroded, minus symbol is there, dilated. It is a very, very important thing. So dilation is the opposite to the erosion, and it is dilation is the expansion of the image. To increasing the white pixels and decreasing the black pixels here, and mathematically white equal to 1, black equal to 0. Dilation increasing the white pixels, we can denote the erosion like this symbol, plus symbols like plus symbol enclosed of a circle. Okay, it is a dilation. So it is one example of dilation. So what is it means? If perfect match equal to 1, partial match equal to 1. But what is the problem means? No match equal to 0. Suppose here I am taking 1, 1, 1, 1 is there. So what is the background here? 1 background 0, 1 background 1, 1 background 1. Here 1 background 1. Is it partially matched? Yes, partially mapped. Then I am taking as a 1 here. Then no matching here. You can observe here 1 1 1 1 1. So in the background 1 0 0 0. Is it matched? No, it was not matched. So we can perfect match. Observe this cell. Observe this one. Above equal to 1. Side all are ones. Background also 1 1 1 1. Is it perfect match? Yes, it is a perfect match. So perfect match equal to 1, partially match equal to 1, and no match equal to 0. That is a dilation condition. But what about the erosion condition? Erosion is a perfect match equal to 1, partial match equal to 0, and no match equal to 0. So it is like this. It is about the dilation. It is one example of after dilation. Before the dilation, that is the input. After dilation, that is the output. It is figure A and it is a figure B. So as the white pixel increased, the image black objects were shrunk. Okay. So you can observe here the different objects are there. Here what happened here? Black is there, but here white. So here black is there, but here what happened? Black. So thin, here thick. Okay. So here what is a disordered image? White pixels are increasing. So what are the black are there? They are dominating with white. So completely compared to this one, white is increasing and black is decreasing. So black objects were shrinking. Black is shrinking, white is expanding. So here miss is continuing with that. Miss is no matches. Hit equal to at least 1 pixel matches. Okay. So hit equal to full match or partial match. That equal to hit. So hit equal to 1. 0 is nothing but a miss. So if miss is nothing but a 0 means no match. So no match equal to miss, that equal to 0. Hit equal to 1 means full match or partially match, that is the 1. So here input matrix is a structure element I am taking here. So it is a dilated matrix. So here this 1 1 1 I am keeping here. So what is happened? Here I am keeping this 1 1 1 here. So in the background is it mapped? No, these are not mapped. So 0. This 1 1 1 I am keeping here. 1 1 1. So background are mapped? No, background 0. If foreground is 0. So all those things like this only. So all are zeros. Here also all are zeros. So I am starting from here also all zeros are there. So there is no map. Here somewhat some whites are there, some ones are there. Okay, we can compare this one. I am keeping this triple one here. 1 1 1. Okay, this 1 0 no, 1 0 no, 1 1 is mapped. Yes, partially mapped. Yes, partially mapped. Next, this 1 1 1 I am keeping here. Where? Here. 1 1 1. All are mapped. Yes, partially mapped. No, yes, partially mapped. Then I am keeping 1 1 here. 1 1 1. Partially mapped. Yes. Next 1 1 1. Partially mapped. 1. Next 1 1. Here blank is there. Partially mapped. Yes. Partially mapped. Next here 0 1 1. Like this. Okay. Next here no 0 is there. Here how I got the 1 means here 1 1 1 mapped. Yes, 1 1 1. Here 1 1 1 mapped. Like this. Here all mapped. These zeros are 0. Why? Because there are no ones are there. So like this. So input matrix, structuring element, and dilation. Input C and output. That is a dilated. Example I am taking binary image. Generally dilation and erosion concepts are there. Here I am taking A. Some matrix I am taking. What is that one means? 5 by 5 matrix. So it is I am taking B equal to 5 by 5. And here A complement A bar. Here I am taking A intersection B. Here A union B. A XOR B. And I of A comma G. Reflection and intersection. So these are the translations. A equal to A bar. B equal to B bar. A intersection B. A complement. So like this I am taking. A translation B. Reflections like this. And here example I am taking using binary image generalization to dilation of the following image. Okay, I am taking this image is a input image, structuring element, and it is a output image. Okay, so understanding dilation and erosion. So how can you understand the dilation and erosion? In the morphological dilation and erosion operation, the state of any given pixel in the output image is determined by applying a rule to the corresponding pixel and its neighbors in the input. The rule used to process the pixels define the operation as a dilation or an erosion. This table lists the rules for both the dilation and erosion. So, in the what are the understanding of dilation and erosion? How can you understand this one? First thing is a first point in the morphological dilation and erosion operation, the state of any given pixel in the output image is determined by applying the rule to the corresponding pixel and its neighbors are in the input. And the rule used to process the pixel defines the operation as a dilation or an erosion. This table lists the rules for the both the dilation and erosion. So what is the operation rule for dilation and erosion? So it is the operation and these are the rules are there. So what is a dilation operation and rule? Suppose I am taking the dilation. What is a rule? The value of the output pixel is the maximum value of the pixel in the input pixel neighborhood in a binary image. If any of the pixel set to the value 1, the output pixel is set to 1. Erosion. The value of the output pixel is the minimum value of the all pixels as in the 0 input pixel neighbors in a binary image. If any of the pixel is set to 0, the output pixel also 0. Here set to 1, also it is 1, 0. So I am taking one example 3. The following figure illustrates the dilation of a binary image in the figure. Note how the structuring element defines the neighborhood of the pixel interest, which is circled. Apply the dilation function and the appropriate rule for the pixels in the neighborhood and assign a value to the corresponding of the pixel of the output. So the following figure is there, that is a binary image. This binary image, we have to apply the dilation. So erosion, dilation. We have to apply the dilation method. Okay, the structuring element is there. Yes, the structuring element is there. That is a 1 by 3. Okay, 1, 1, 1 is there. Suppose the concept is there. I am keeping the background 1, 1, 1. Is it mapped? Yes. Any of the one thing is mapped? Yes, 1 mapped. Here 1, 1, 1, 1. Anything mapped? No, it is 0. Next, is it any mapped here? Yes. If there is no means all are zeros. If here I am taking 1, 1, 1. Is it mapped? Yes, it is mapped. 1, 1, 1. Mapped. 1, 1, 1. Is it mapped? Yes, it is mapped. Here 1, 0, 0. Mapped? Yes, mapped. Next 0, 0, 0. No mapping. So 0, 0, 0. No mapping. 0, no mapping. Like this. Okay. So like this, I am getting the input with the structuring element. I am getting the output or the eroded output. Here I am applying the dilation function to operate pixel to the neighborhood of the corresponding output image. So it is the output, that is dilated output. So example 4, apply dilation and form the matrix with a suitable example. I am applying the dilation. Okay. Here the input is a 0, 0, 0, 0 like this. Okay. 3 by 4 matrix is there. What is the structuring element? 3 by 3. So this I am dilating here. So this I am keeping 0, 1, 0, 3, 1 like this. Okay. If I am keeping like this, what will happen? 0, 1, 0, 1, 1, 1, 0, 1, 0. Is it mapped? F. Is it partially mapped? If it is partially mapped, then it is keeping as a 1. Okay. Where it is keeping? This 3 by 3 I am keeping here, here, here and here. So how many mapped? Then 1. If not mapped means 0. So that is the output binary image. Okay. And construct eroded image with a suitable example. Okay. I need a eroded output or dilated output. But here I am taking both eroded, here question. But dilated also I got this one. Original image like this. Okay. 1, 2, 3, 4, 4, 5. 1, 2, 3, 4, 5, 6. 6 by 5. It is the structuring element SE. So if I am adding this one, dilation and erosion. So I am mapped with 1. I am comparing this all those things. Okay. How many are mapped? If mapped means 1. If not mapped means 0. Here what will happen? Background will be improved. So here what will happen? Object will be improved. Okay, like this. Okay, number of ones are improved. Once improved means white improved. Here what will means black improved. Black means zeros are improved. Okay, so so in the dilation is a process in which the binary image is expanded from its original shape, and the way of the binary image is expanded in determining by the structuring element SE. So the structuring element is a smaller in size compared to the image itself, and normally the size is used for the structuring element is 3 by 3. The dilation process is similar to the convolution process. That is, the structuring element is reflected, and it is look for any overlapping pixels between the structuring element and that of the binary image. So So it is a input image and a structuring element and a dilated image, and it is a erosion is the counter process of dilation, and the dilation enlarges the image into the erosion, shrinking the image. And the way the image is shrink is determined the structuring element, and the structuring element is normally smaller than of the 3 by 3 in size. So the computation time is compared to the larger structuring element is SE. Almost similar to the dilation process, the erosion process will move the structuring element from left to right and top to bottom. At the center position indicated by the center of the structuring element, the process will look for whether there is a complete overlap with the structuring element or not. Okay, so if there is no complete overlapping, then the center pixel indicating by the center of the structuring element will be white or 0. So, okay, when I am taking the white equal to 0, that is black equal to 1. And the equation states that the outcome element is considered only when the structuring element is a subset or equal to the binary image. And the erosion process starts at the position. If there is no complete overlapping, the pixel at the position will remain white. But the structuring element is then shifted to the right and the same condition is observed. So the structuring element is then shifted further until its center reaches the position marked. Here we see that the overlapping is complete and the black squares in the structuring element overlapping with the black squares in the image, and the center of the structuring element corresponding to the image will be black, and the figure B shows the result after the structuring element has reached the last pixel. Erosion is a thinning operator that shrinks an image. By applying erosion to an image, narrow regions can be eliminated while wider ones are thinned. So it is the input image and the structuring element. It is the eroded output. So what is the eroded output means? What will happen? Erosion method. Black is shrinked. Black is shrinked. White is improved. So white is improved here. White is improved and black is shrinked. So the erosion is one of the most useful and simple morphological operation in digital image processing. At the name means erosion takes away the pixel lies in the border of the image or it takes away of the irrelevant shape detail in the object. In other words, erosion shrink the image. Okay, so erosion shrink the image, dilation improve the image. Okay, expanding the image. So as per mathematical values, white is nothing but a 0, 1, black is a 0, and we are considering as the erosion decreases white and increasing the black area. So actually morphological operations are 5 types: erosion, dilation, closing, opening, and hit or miss transform. Okay, it is one example of erosion. The perfect match equal to 1 and partial match equal to 0, no match equal to 0. Okay, so this matrix I'm keeping in the everywhere is the background. Okay, I'm keeping here, 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 here like this. Okay, so if no match equal to 0, if partial match, then perfect match equal to 1. Why? Because partial match is also 0 and no match equal to 0, but perfect match equal to 1. Okay, that is the concept of erosion. It is a image after eroded, means what happened here means the black cells are improved. Okay, and here we can observe that the object of image is thicker than the original image. Okay, it is thick somewhat compared to original image. In the dilation means it is a thin. Okay, like this means light color is the dark color. So we can observe that the objects in the image are thicker than the original after erosion. This is because of the background color is white, and after erosion the white color, white pixels are be increasing. Here dilation is opposite to the erosion, and dilation expands the image, and it increases the white pixel and it decreases the black pixel. That is, white is improved, white is improved, white is improved, and black is decreased. Mathematically, we know that black equal to 0, white equal to 1. So the dilation increases the white pixels, and we can denote the erosion as the symbol erosion, and it is a dilation. Okay, so it is a dilation. What is the condition means? Perfect match equal to 1, partial match equal to 1, no match equal to 0. So before dilation, it is a after dilation. So in the white pixels increased, the image black objects were shrinking. Okay, black objects were shrink. So black are shrinked. Okay, miss equal to no change, that equal to 0, hit equal to 1, that is hit equal to 1, that is partial match or full match. Okay, it is the input image. Multiplying the structuring element, it is the output image. Okay, input matrix, structuring element, and dilated matrix. It is one example of binary generalization, dilation, erosion. A equal to A complement, B equal to B complement, A complement, A tends to B, A inverse B, like this. Have translation, reflection. These are the performance of binary image, and it is a generalization to converting the dilation of the following. Okay, it is the input image, and it is a structure element, it is an output image. What are the understanding or conditions for the dilation and erosion? The morphological dilation and erosion operations, that states of any given pixel in the output image is determined by applying a rule to the corresponding pixel and its neighbors are in the input. The rule used to process the pixel defines the operation as a dilation or an erosion. This table lists the rule for both dilation and erosion. So what are the rules means? Dilation, the value of the output pixel is the maximum, it stores 1, and erosion means the value, the minimum value is there, the pixel stores the 0. Okay, it is one example for finding out or applying the dilation. Here applying the dilation to form matrix with a suitable example. Here I am taking one matrix, that is a 3x4, 3 rows and 4 columns, and it is the structuring element SE. So using this input and output and dilated output. Okay, so it is a construction of eroded and dilated images. Okay, input is the original image, structure element, dilated, eroded. Dilated means number of ones are increased, number of zeros are increased. That is a simple thing. Number of ones means white colors are improved, number of zeros means black colors are improved. In the erosion, black is improved. In the dilation, white is improved. Okay, these are the references. It is about the dilation and erosion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.